Hello world, it's Siraj, and today we're going to talk about DeepMind's StarCraft II AI environment. So recently they released this StarCraft II environment that lets you train reinforcement learning models, and that's what you're seeing right now. It's a demo of it happening. But basically, you can use StarCraft II, the game, as a test bed to train and run your AI models on. And these can be reinforcement learning models, they can be deep learning models, they can be really anything. They can just be scripts that aren't even machine learning, just like hard-coded bots, whatever. But the point is that it's meant to be a test bed for people to train and test their AI models on. So it's a really exciting time right now for deep reinforcement learning as a field because OpenAI beat Dota 2 recently in the World Champion. They beat the World Champion at Dota 2, and then after that, DeepMind releases StarCraft II AI environment. So there's a lot of exciting things happening right now in deep reinforcement learning. There's a lot of low-hanging fruit in this section of machine learning, as opposed to supervised learning, where a lot of it has been solved more or less, right? Gradient-based optimization. You compute the gradient and then you update your weights and you know your labels. It's very, it's been tried and done before. But for deep reinforcement learning, there's a lot of unanswered questions. So it's a really exciting time right now. What we're going to do is we're going to run a pre-trained model. And what I'm going to do is I'm going to, on my machine, set up and install all the required dependencies and the script, everything you need basically to go from 0 to having StarCraft II running on your computer with DeepMind's environment installed and a pre-trained model running, okay? So what the model is it's called a deep Q learner. I'll talk about what that is, but it's a deep Q learner, and it's going to be running on the collect mineral shards MIDI game of StarCraft II, which means it's just a bot that's collecting little trinkets called mineral shards, and it'll do this autonomously without you needing to do anything. And so from there, you could modify it or run your own algorithms. But once you have something set up, it'll be a lot easier to get into the bot of things. What am I doing with my hands? Okay, so let's get to this for a second. Okay, so first things first, what is the history here? So DeepMind's first attempt at running game simulations came for Atari games, right? That's why Google bought them. They created an algorithm called the deep Q learner, which is the algorithm that we're running. And they use that algorithm to beat any Atari game. And the way they did this is they combined two different ideas in machine learning. They combined the idea of deep learning, which is all about learning features. You don't have to engineer what those features are. Like, I'm looking for a dog that has long ears and it has brown fur. No, it will learn what the necessary features are to map what it sees to some label. And so they used a convolutional neural network for this to create features, learned dense representations from game screens, right? So all it got were the pixels of the game, the pixels, and then it learned dense representations from those pixels, and then it converted what it saw into an output, and that output was an up, down, left, or right value, right? Anything that you can use on a joystick for an Atari game. And the way it did this is it didn't just take in the input from what it saw in the game, it also used what's called Q learning. Q learning is a type of reinforcement learning where we initialize what's known as a Q matrix. And the Q matrix is a collection of possible actions that an agent can take in a game. And all of these actions are weighted. Like, this is an okay action, this is a better action, this action could be the best action. And what it does is it picks an action from the Q matrix using some strategy that you decide. It could be random, it could be based on some pre-weighted value like an epsilon, whatever. But you pick an action from the Q matrix, you perform it in the game, you observe what's happening, and then you see if you got a reward or not, right? A +1, a -1, and then based on that reward, you'll update the Q matrix so that the actions are all weighted differently, right? And so the idea is that eventually the Q matrix will have the best actions for you to perform at whatever time step you're in, right? The Q matrix acts as a weight, similar to how in a neural network the weights improve over time. In reinforcement learning, in Q learning, the Q matrix improves over time. So they combined both of those ideas together, right? So deep Q learning. And the way it does this is, and I've got a little bit of pseudocode here for how it works, and this is the full pseudocode for how their algorithm works. Now keep in mind that their algorithm wasn't just a simple take a convolutional network and then run Q-learning on top of it. It's also got two different features from neuroscience that the first one is called replay memory. And replay memory is essentially a buffer in memory, that's a temporary buffer that stores states, actions, and rewards. Basically your experience of what has happened in the game. And this improved their AI when they used this concept of replay memory that acted as a temporary buffer that they could pull actions from, as well as the Q matrix. So if we look at this pseudocode, we'll see that first it initializes some replay memory matrix, it initializes a Q matrix randomly, and it observes the initial state of the game. Where are we in the game? And that would be the collection of pixels that it first sees. And then it runs the training loop. So in the training loop, it will select an action from the Q matrix, either randomly by using some probability value epsilon, or by selecting the optimal Q value from the optimal action from the Q matrix that it sees, and then it will execute that action in OpenAI's universe environment. They call this the step, right? The environment step function. So it will execute the action, and then it will observe the reward that it receives, and it will store the state, the reward, the old state, and the action, all of those those four values into replay memory. And then the next step is for it to compute a loss function. And we can see the loss function here. It's also called the Bellman equation. Okay, this is also called the Bellman equation. Not to get you too confused, but that's just what it's called as well. But basically, it will randomly sample from the replay memory, and then it will use a sample that it retrieved to compute a loss function, and then it will minimize the square of that loss function at every iteration. And as the loss function is minimized, the Q matrix's values are improved at every time step, which means that eventually, every time the agent pulls an action from the Q matrix, it's going to be more and more optimal, such that it's going to minimize the loss, which will maximize the reward it receives. I know that's quite a mouthful to say in 30 seconds, but that's how the deep Q learner works at a high level. The next step for them was to try it out on Go, the ancient Chinese game of Go. So a lot of AI experts said that it would take 10 years, 20 years, 30 years for an AI to be able to beat the game of Go, because there were so many possibilities, right? There's so many possibilities, and the search space is far too vast for an AI to just brute force through all the options. There's so many different combinations of game states that it's just too hard for an AI to compute with the limits of computing power that we have now. That was their thinking, but they were wrong, because they're always wrong when it comes to deep learning and all these new technologies. But basically, AlphaGo was their successful attempt at beating the game of Go. And they used two different neural networks here. They actually used three. They used three different neural networks. They used three different neural networks here. One was for the policy network, and one was for the value network. And both of these computed two different values. One is the policy, and the next is the value. And it used both the policy and the value to help guide what is essentially a gigantic tree search. And the tree search is called a Monte Carlo tree search. And here is a brief description of how it works. But basically, the Monte Carlo tree search, or MCST, simulates a search tree, and the AI selects an action at each time step based on the action value and prior probability, which is the output of the policy network, and some exploration parameter. So it uses the values of the policy network and the value network as guides to help it search the tree of possible moves that it can play at every time step. And they trained AlphaGo on tens of thousands of hours of expert gameplay, and then they gave AlphaGo to the world champion Lee Sedol, and it beat Lee Sedol. So beating the game of Go was a much harder challenge than beating the 20 different Atari games, given just the pixel values of the game screen, right? But now, more recently, they decided let's up the ante even more, right? And they decided, let's not just do this alone. Let's open source this so that everybody gets to use this technology, right? So StarCraft is arguably one of, if not the greatest PC game of all times. PC fanboys always come at me. But anyway, StarCraft is one of the best PC games of all time. And it's got hundreds of thousands of players across the world. It's got people whose day job is to just play StarCraft all day competitively, right? In South Korea specifically. Much love to South Korea if you're out there. But anyway, StarCraft II, huge, awesome game. If you've never played it before, then this is a great opportunity to download it. It's free. I'll show you a little bit about that in a second. And if you have played it before, this is a great way to help improve your own strategy, right? Because when you're building an AI for StarCraft II, you're thinking about all the things that it requires to be a good StarCraft player, right? When you're thinking about when you should spend your wealth, how you should build your army, what you should invest your resources and time and energy in, all of these things you're going to try to want to replicate in an AI that you build. And so if you think about an AI for StarCraft, it has to be able to do a bunch of things that are quite difficult. First of all, it's got to have an effective use of memory, right? It's got to be able to remember not just the things that have happened in the short term. It's got to be able to remember the things that happened back in the long term, in the past. And not just in the past, it's got to be able to plan over a long period of time. Sometimes you want to make decisions that help maximize your current value, right? You want to kill an enemy because the enemy is next to your, vulnerable troops. But other times you want to make an action that is not as intuitive in the short term, but in the long term it is, right? Like sometimes you want to spend a lot of money on some resource, and so you're going to have little money right now, but in the long term that resource that you purchased is going to help you a lot more, right? So it's not as obviously intuitive as something like an Atari game where it's just like all you have to do is defeat, get from point A to point B, or remove some block, or kill all the aliens on the screen. It's not that simple, right? And even some task as simple as expand your base to some location is actually pretty complicated. You have to coordinate mouse clicks, your camera, available resources, and what this does is it makes actions and planning hierarchical. And this is generally very hard for reinforcement learning algorithms to grasp. The concept of hierarchy is quite hard for reinforcement learning algorithms to grasp, right? Because you're performing an action and you're receiving a reward, right? So there's the agent environment loop. It's not like a deep learning where we have all of these layers and there's all of this structure that's built over time. So deep Q learning was one good example of having a hierarchical structure, a hierarchical model in a reinforcement learning environment. And I think it was one of the first, but we're going to see a lot more. And a lot of the key discoveries that are going to come out of the entire field of machine learning this year and next year are going to come from deep reinforcement learning. When some really smart people combine the ideas that come from deep learning, mainly hierarchical learning, and the ideas of reinforcement learning, from learning from an environment in real time. Andrej Karpathy had a recent talk at Y Combinator, I think it was called YConf, where he said that AGI, artificial general intelligence, is going to result from having simulations, right? From creating an AI that can adapt in a simulation, similar to how we adapt in the real world. And this is a simulation. Enter Twilight Zone music. But anyway, so reinforcement learning, deep reinforcement learning, super hot field, and this is your chance to get into it, right? You don't have to work at DeepMind, you don't have to work at OpenAI, you can just be some kid who has the time and energy to work on this stuff. And if you have internet access and you have the time to work on this, you too can make an amazing algorithm. And you post it on GitHub, you post it on Hacker News, on the machine learning subreddit. You'll get great feedback. You can join some online research groups on a Slack channel or on several of the forums online, and you can just do great work. And all of this can be added to your portfolio, your GitHub, your resume for future prospects, whether that be studying at a university or working at one of these fields. But the point is, in order to get anywhere, you've got to do something, right? And StarCraft II is a great test bed. It's a great set of tools. I've tested it out myself, and I think it's a really great place to get started with deep reinforcement learning. Okay, so now so onto the code, right? So Basically, so it was a joint collaboration with Blizzard. So Blizzard already released an API that lets a user create scripted bots, machine learning based bots that are running from pickle files, pre-trained models, replay analysis, and tool-assisted human play. And so DeepMind's environment, its repository, is called PySC2, Pi StarCraft II. So it's all in Python. Thank the Pi gods, right? It's in Python. But it has 4 components to it. The first is the API that it wraps from Blizzard in Python. The next is a data set of anonymized game replays. Okay, so it's got a lot of these anonymized game replays that you can download from right here. I'll go through that in a second. And it's got a series of simple RL mini games. One of them is what we're gonna do for this demo, and to test out different environments, right? To test out different algorithms, I mean. So this was Blizzard's initial API, and then DeepMind wrapped it with their own Python repository, right? So what we're gonna do is we're going to just set up everything, right? So I'm gonna go through these installation steps. There are 7 steps here, and I'm gonna go through all of them to get started, okay? So first of all, before you do anything, you've gotta download StarCraft II, the Blizzard client. It's free. You just sign up on Blizzard and you select the starter edition, right? That's it. Just select the starter edition and it's free. And you can just download that and then you can play it just like that. It'll take, depends on your bandwidth, but it took me about an hour to download and set up. And already I was running through the tutorial in StarCraft II, right? Just an hour for me. So definitely download that, and once you've downloaded StarCraft II, then move on to these 7 steps. So the first one is to install PySC2, right? And so luckily they have wrapped it into a nice little Python library for us. So I can go ahead and install it using pip. So I'll say sudo pip3 install PySC2. Okay. And it's downloading. And it's building off of all those dependencies that, right, it's built on top of the Blizzard API that I just talked about, and some other things. Okay, so now that was step 1. We've installed PySC2, and so the next step is to install the sample code. So the sample code, you can just clone it directly from my GitHub, just like git clone, and it's going to download it. Just like that, right? And the sample code contains the pre-trained model, and it contains all the Python files you need to run this very simple reinforcement learning bot. And so once you've got that, then that's step 2, and then step 3 is to download the mini games from the StarCraft II maps, right? So we can click on this link, and just like that, here are our maps, our mini game maps. Okay, and so we can move all of these into our folder for StarCraft II, and it's going to be in the maps folder, right? Here we go in maps. So I'll just copy and paste it just like that. So now my StarCraft II application that I've downloaded with the Blizzard client has these maps. And so once I have these maps, now I can install TensorFlow and OpenAI baselines. Oh, okay, so right, if you don't have TensorFlow, you can install TensorFlow with pip3 or pip install. You can install TensorFlow. I've already got TensorFlow. And then once you've got TensorFlow, so TensorFlow is to be able to train and run these machine learning models. And then you have to install OpenAI baselines. So baselines is a collection of high quality reinforcement learning algorithms, right? The DeepQ network is one of them that we're gonna be using, and it's got policy gradients, which is another popular reinforcement learning algorithm. But basically, it's your way of being able to implement these reinforcement learning algorithms without having to code them from scratch. And then you can modify existing ones, tweak them to see if you can get better results. So it's a good way to test around with test some different effects. Okay, so then I can download the baselines environment. And once I've downloaded baselines, I've put my folder, I've put my maps into my StarCraft II folder, then I can go ahead and open the project with IntelliJ. So the reason I say use IntelliJ for this and not just open it with Sublime or some regular text editor is because this, hold on, permission error. Of course, we got to do sudo. Of course, there we go. So the reason I say IntelliJ is because there's some logs that are really nice to view when it comes to how your agent is running, which is easy to do with IntelliJ. So if you've never used a an IDE, an integrated development environment like IntelliJ, this is a great reason to do it, right? So go ahead and download IntelliJ. You can download it from here. There is a paid version, but there's also a free version, the community version. Get the community version so you don't have to get the paid version. And then if you want to train the model, right, from scratch, then you can run Python 3 train mineral shards.py. But what we're gonna do is we're gonna run a pre-trained model so that we don't have to train it from scratch. We just wanna get something to work, right? So let's go ahead and just open up that model. Okay, so IntelliJ is opening right now, and once it's opened, I can go ahead and open my project. So I'm going to import a project, and where is my project? So my project is in downloads, PySE2. So I'll go to downloads, PySE2 examples. All right, and then I'll open it. From existing sources, finish. You can install plugins to support Python, which I'll do right now. So clearly I'm doing all the steps as if I've never done any of this before. And then I've got to restart it to initialize the Python plugin. Okay. All right, so now I've got the code imported into IntelliJ, and it's detected a Python framework, and I'm going to say OK to this, and then and there we have it. And now the client is running in the background. It's executed StarCraft II. It's detected that my system has StarCraft II installed, and then it's run this script to run a pre-trained model inside of the StarCraft II environment. So it's able to access the StarCraft II game because DeepMind's PySE2 repository under the hood, it's using Blizzard's API, but it's a local API, so it's not like it's connecting somewhere remotely, it's connecting to the game that's right on your desktop or your laptop. In terms of the code, the model and the environment are built from us. So in this code, it's got the deep convolutional network right here. You can see the parameters are here, the number of hidden layers are here, and then it's got it's wrapped that OpenAI environment.step function, right? So it's given it these parameters, and it's combined both the convolutional network and the Q network together to then train this AI, and it saves it as a pickle file. It saves the pre-trained model as a pickle file, and then once it's trained the pickle file, we can access that pickle file to run the pre-trained model in the DeepMind environment, in the StarCraft II environment. And if we look at this code, it's actually, it's quite a lot of code, and I can make a different video to talk about how all the code works. But right now, I just wanted to help you install and configure this script so that you can run it yourself. Don't be afraid to run it. It's actually pretty easy, and all in all, including downloading StarCraft II, downloading the code, installing all your dependencies. It'll take you probably an hour and a half to go from 0 to running your own RL algorithms in this game, okay? So I hope that helped. Please subscribe for more programming videos, and for now, I'm gonna play some StarCraft 2, so thanks for watching.